All right, still with the no-calc. We've got f being the function defined by the integral from 0 to x of this function. On which of the following intervals is the graph of f of x concave down? So to find concave down of f, we want where its second derivative is less than 0. So if f is that function, f prime, and we keep assessing this, is the derivative of the integral, which would just be, in this case, putting x in there. And then so its second derivative would be, let's go ahead and erase that guy, 6x squared minus 30x plus 36. And if we find when that's equal to 0, we can find the other parts where it's either positive or negative. Looks like we can factor out a 6, get this guy factored. X squared minus 5x plus 6. Oh, there's a good factor. That to multiply to negatives to positive 6 would be x minus 3x plus, nope, x minus 2. So it equals 0 at 2 and 3. So if I check outside those, so if I put in a 0, I get a negative times a negative, which is a positive. If I check in between, like 2.5, this one will still be negative, but this one will be positive. And if I check above, they're both going to be positive. So I am negative from 2 to 3. There it is. Here's our horizontal asymptote discussion when it's our degree discussion. So when our degree in our denominator is greater than our degree in the numerator, that is when our limit equals 0. So which one's going to win the race? Right here, we've got logs always lose. So this one is a winner. So I'm thinking this one's going to for sure be it. Exponentials always win and beat logs. So that one's going to be an infinity. And then this is the one that, like if we had that race in pre-calc, x to the 99 looks big, but exponentials always win. So this one, the numerator, so it's going to be 1 and 3. All right. F be a differentiable function such that f of 0 is negative 5, and f prime is less than 3 for everywhere. Which of the following is not a possible value for f of 2? So it can increase by less than 3. All right. I love this question. So it could be as high as, let's say it went 3. It could go all the way up to 1. So I would think this would still be in play. Let's take a look. Negative 10 is fine because it would go down 5, which is less than 3. I mean, we can go down. Could stay, could be a 0. That's less than, its increase is less than 3. 0's fine. Yep. So E is the only one it couldn't be. Even if it went up 3 consistently from negative 5, it could only get to 1. So I'm not circling 1, but the highest it could get was 1. So our answer has to be, which one could not be, would be that one. Let's look at 14. F of x is this piecewise function, x plus b, if x is less than 1, and ax squared, if x is greater than 1. What are all values of a and b for which it is differentiable at 1? So that means they have to be equal and their derivatives have to be equal. So let's find some of those equations. X plus b has to be equal to ax squared when x is 1. So 1 plus b has to be equal to a. And then their derivatives would be 1 has to be equal to 2ax, again still at 1, so 1 equals 2a. So then we can find right away that a is going to be 1/2 just by taking the derivatives and setting them equal. If a is 1/2, b is going to be negative 1/2. Good. So function equal, derivative equal is differentiable. 15's got a little quotient rule assessment for us. We'll find the value of k prime of 3, and k is f of x over g of x. So let's take a look. K prime would be bottom d top minus top d bottom over bottom squared. And then I think we can just put numbers in. K prime of 3 equals g of 3 times f prime of 3 minus f of 3 times g prime of 3 all over g of 3 squared. So let's write them out. G of 3 is 2 times f prime of 3 is 5 minus f of 3 is -1, g prime of 3 is -2, all over g of 3 squared. 10 minus 2 would be 8 over 4 should give me 2. Math it up.